my talk, Let's Talk Databases in Python. But first, before we get started, a little bit about me. Why am I giving this talk? I started out my career working at Intel on a Flask application for data analysis, and there it talked to MySQL. Next, I worked at Hypothesis, building a pyramid React application for annotating web pages, and it talked to PostgreSQL. Currently, I work at New Relic as an application developer for the security team, and there we also have a Flask application that talks to PostgreSQL. A little extra tidbit, I gave a talk at PyCon last year as well on the pandas library, and something that came out of that, which I'm super excited about, is I will soon be a published author of the book Thinking in Pandas, which is based on that talk. So if you enjoyed that talk last year or you're at all interested in learning pandas, definitely check that out. It's published by A Press and should be coming out in June sometime. So jumping right in, what is an ORM? So ORM stands for Object Relational Mapper. So the idea is we have our objects over here on the right, and those map to tables in our relational database over here on the left. And so an ORM is responsible for building that mapping between the two. And so what ORMs are available to us in Python? We have SQLAlchemy, Django ORM, Peewee, Pony ORM, SQL Object, Todos ORM. There are a lot of them. But today I'm going to be talking to you about how to use SQLAlchemy. It's seen as a very nice ORM by the Python community. It has a good generalized abstraction and query language that's database agnostic, but it also allows you to do database-specific things if you need to. So let's look at an example. So we have a bunch of what I will refer to in the rest of this presentation as models, which are the SQLAlchemy classes, which represent our tables in our database. And so here, let's take a look at what the user model looks like. So here's our user model class. It's inheriting from this base class that I'll talk about in the next slide. So here we're providing the table name user, and then we have several columns. So we have an ID, we have an email, a username, a password, and a last login date. So in here, you can see we can do things like set the primary key and auto-increment the primary key, which what that means is SQLAlchemy is going to take care of this for us. It's just going to start the ID out at 0 and then keep incrementing it over time automatically. We also have an email address that is unique and it's indexed and it is not nullable, which means it can't, you have to define it. And then we, of course, have a username and a password. Those are pretty standard. We also have this last login date, and something that's kind of interesting about that is if you look down there in the definition, you see that server default equals SA func now. And what that is doing is it is going to go all the way to the database without having set this timestamp, and it's going to actually set the timestamp on the database at the time that we write the user to the database. So that's really nice. It's also kind of like a best practice is to be very consistent about where you set your timestamps, and generally you want to do that on the database side. So let's take a look at that common base class that the user model is inheriting from. This is also pretty standard stuff. It's pulled directly from SQLAlchemy documentation. So here we're just providing some kind of like standard naming conventions for the columns here. So we have IX, meaning index column, unique, etc. And then we're importing this declarative base class, declarative base function, which will make our base class for us. So we pass in the metadata, and then SQLAlchemy generates this base class, which we'll use for all of our models that we build. You can also do validation inside of these models. So here, for example, we are validating that the username is within a certain length and that it also contains certain characters, or doesn't contain certain characters, as the case may be. You do have to be a little bit careful about this. Remember that validation at the database level or at the SQLAlchemy model level is kind of like a latched ditch validation before it enters the database. So this may or may not be the best example, which is why I chose it, because this is kind of talking about like the gray areas and the design decisions that you may need to make for your application and your models. So here, this may not be the best place to do this validation, is my point. Something like checking the username for certain characters, that's probably something you would want to catch before it reaches the database, probably on the front end. Like it's something where the user would enter their username and they would immediately get feedback and it would say, hey, like these characters are not allowed in your username. You wouldn't necessarily want to go all the way to writing to the data, or almost writing to the database before this error pops up, right? But anyways, it can do validation for you, which can be really nice as like a safeguard and like a last ditch, like, hey, oh no, don't write that sort of thing. So anyways, we can also define relationships between our tables. So for example, here we have a relationship between the user model and the group model. So here, the group has a creator ID, which points to the a row in the an ID of a row in the user table. And so how we define that in SQLAlchemy, we have this creator ID column, and that's set to be a foreign key of user.id. And then we also have this creator relationship to user, which will allow us to do things like query a group out of the database and then say group.creator and get any column name or field off of the user object. So we don't just have the user ID, we actually have like full access to the user object if we want. We can also do unique constraints. So for example, we might not just want to have a unique email or a unique authority, but like a unique email authority combination. And in this case, authority is really domain. So we're saying for each like authority or domain, the user email must be unique. The user email and the combination of the domain must be unique. We can also define a multi-column index, and what that means is we would like to pull a single user out of the database, a unique user. And so our queries may look something like this, where we say where username equals user and authority equals some authority. We might also do queries just based on the username itself. However, we never do this bottom query, which is just query based on the authority, because the authority is not narrow enough to give us back just a unique user. And this is very important. And the order for this is very important. So notice we have username and then authority after. So we're saying like we may query uniquely on the username and query uniquely on the username and the authority combination, but we don't query uniquely on the authority. And so we're just creating a unique index for that. We can also do partial indexing. So in this application, we did something called shadow banning, which is where we have a user may violate the community guidelines, and in this example, the user did just that. They're using annotations for selling their product, advertising, and that's not allowed. And so how we shadow ban them, like what that is it's basically, this is what they see, everything looks fine to them, but this is what the rest of the world sees. They see nothing. Their annotations have been shadow banned. And so how we how we present the annotations and filter out all the shadow banned annotations is we do a query for all the annotations, and then we filter them after the fact. So we do a separate query and get all the shadow banned users, and then remove or strip out all their annotations before we send them to the front end. And so in that situation, in order to make that grab all the shadow banned users query efficient, we have this NIPSA field, which when true means it's a shadow banned user, and we just create a partial index where NIPSA is true, and we index all the NIPSA true users so that they're very quick to look up and find. We can also define or do functional expression indexing. So what this is we have a thread of annotations, so you can make a root annotation and make a reply to that annotation, a reply to the reply of that annotation, right? And so how we define that in the database is we have this references list, which is which contains the parent annotation, the annotation's parents. And so on this root annotation, for example, the references is empty. On this reply to that root annotation, the references list points to the root, right? And on this reply to the reply, the reference points to the root annotation and then the reply to the root annotation. And so we, in order to find the annotations, basically like what we do is we grab all of the root annotations that we want to display on the page, and then we run a separate query and grab all of the replies to that root annotation. So we want to, so we might do something like this where references of 0 equals the root annotation. And we want to make that lookup very fast, right? We want to index that lookup. And so notice that we're doing like references of 0, right? So we need to index that root annotation, or that like index of 0 annotation. And so how we do that is we use a functional expression index, and we index the references of 1 in this case, and it's 1 because we're in Postgres, and Postgres uses 1-based array indexing, so it's 1 and not 0. All right, so we've talked about some ways to index and improve our queries, make them more efficient using SQLAlchemy. Let's dive into actually connecting to the database and grabbing some data. So how we do this is quite simple. You import the create engine function from SQLAlchemy, and then you create an engine, which you basically just pass in the URL to the database, and it creates an engine for you, and then you bind that engine to a session. And so here we have this session maker, which again is dumping out a session class for us to use, which is why it's capitalized there. And so how we use that class is we instantiate an instance of it, and then say we make a user object, we add that user object, we commit that user object, it gets written to the database, and then don't forget to close your connection afterwards. This is very important. And so in order to kind of like facilitate this opening and closing of connections and remembering to do all these steps, we could also create a context manager to do that for us. So this is what that looks like. We instantiate the session, and then we yield the session, and that is where we, that's that first part of the with statement. So now we've entered the with statement, so we've yielded the session to the internals of the with statement. It's going to add the user, commit the user, and then it's going to yield back into the session manager. If an exception was raised for whatever reason, we're going to clean ourselves up, so we're going to roll back the session and re-raise the error. Otherwise, we're just going to close the session because everything worked great. And so yeah, in this scenario, kind of like doing like file I/O using a context manager, we don't have to worry about opening and closing it. Kind of handles that for us, which is nice. Which leads me to my next point. How should you scope your sessions, right? What's the scoping of this thing? So in a web application, a session should follow the lifecycle of the request. What does that mean? It means when the request comes into your application, that's when you open a session. When your response is sent back from the web application, that's when you close the session. And that is how your sessions are to be scoped. So you might think that a session is establishing a database connection each time. That is in fact not the case. And we'll talk about why that is in a second, but this is what it looks like to establish a database connection. It's very slow. It first sends a SYN and to the database, and then it sends a SYN ACK back from the database, and then it sends an acknowledgement to the database. So this is like 3 times back and forth across the network. It's very slow, very time consuming. We really don't want to be opening and closing database connections each time we run a request. So luckily for us, SQLAlchemy is smart enough and it magically handles this for us. So it uses something called connection pools. And what a connection pool is it is a pool of connections, shockingly. So these connections stay open. Once they've been established, they do not close. They just go back in the pool. So when we create a session, we're not actually creating a database connection. We're just grabbing one out of the pool. It's already been established. We use it, and then we put it back in the pool for somebody else to use. When we generate our, when we build our engine, we have some options for the pool settings. So here you can see you have the pool size, max overflow, timeout, use LIFO or not. These are I think like the default options that I wrote here, but you have control over them. So what this is saying is we would like a pool of 5 connections with a maximum overflow of 2 connections. So what that means is like if all 5 connections are in use, then it will create 2 more connections when a session is requested, but it won't keep those alive. It will close those down after they're no longer needed. And then we also have a timeout of 30 seconds on any of those connections. So if we don't receive any data for 30 seconds, or like if no one's used it in a while, then it just closes by itself. We also have this option, use LIFO. So what that stands for is last in, first out. So what that's saying, and the default is false, but we could set it true. And if we do, what that's doing is it's the connection that goes that was most recently used and put back in the pool is the same one that comes back out of the pool immediately the next time somebody requests a session. And so what that's going to do is it's basically going to let old connections die. And so this is kind of like a way to scale your traffic up and down and get rid of connections that you no longer need. So what this looks like as far as a connection pool is concerned is the connections that aren't used slowly die. And this is a common problem as well. They just kind of start dying if they're not used in a while. And that's very unfortunate for us because if you're not constantly receiving traffic, then your connections are going to die. And then the next time a request comes in and queries the database, then you're going to have to reestablish that connection. And you don't want to do that. Like, you want to keep your connections alive, and you want to keep your application always responsive. And so in order to do that, we can actually specify some TCP keep alive settings in our connections so that our connection will ping the database and keep itself alive every 60 seconds in this scenario. And so now, ta-da, our connections are always alive, always happy. So we can also do querying with our SQLAlchemy session. So just like before, we're inside the context manager of the session. We query for the user. So we're just grabbing the user out of the database in this case, and we specify a qualifier on that query, 1 or none. So what that's saying is we expect to get 1 user back or no users. And there are many of these qualifier functions, so we could use all, count, delete, distinct, exists, first, filter, join, limit, blah, 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 blah. And there's a bunch more of them in the docs that I have a link to there. You can also, if you desire, print out the exact select statement that is used to query your database via this guy here. So user statement compile, pass in your engine, and it'll spit out what the exact select statement was that was sent to the database, which can be useful for debug. Another thing that I don't have on this slide that's also used for debug is you may find yourself in a situation where you have some sort of monitoring in place, and your monitoring tells you that you have a certain query in a request that's slow, and it doesn't necessarily tell you which line in your code that query is coming from, but it gives you the select statement that it used. So something you might do in development to kind of figure out where that line is coming from is if you turn the SQLAlchemy debug option on, then it will print out all of your select statements that are used and run. And so from there, you can kind of like narrow it down and find where that particular slow select statement is coming from and fix it. So here, normally you do want to work in this way. You don't necessarily want to start with a database that already has tables in it. It's preferable to start with an empty database and use SQLAlchemy to generate your tables, although you don't have to. And that's just to make sure that your models exactly match what's in your database. But anyway, so if we want to do that, we import our models, and then we use that base class and say base metadata create all, and that will create all of our models as tables inside our database. So we've talked a lot about how to use SQLAlchemy. Now let's talk about how to migrate data. And so what is a data migration? It's when we make or delete a new table, add, remove columns in a table, modify existing data in a table. And why is it important? Like, why would we want to use a migration tool rather than just running a SQL statement directly on our database? There are several reasons for this. One is it allows us, it prevents human error. So once we write the script, we write it in a script. We know that it's correct. We can test it locally to make sure that it works. We can have our fellow developers review it before we run it. And then when we run it on production, we have some sort of guarantee that it's going to work as expected, or at least that we have tested it as much as we can. And are more confident that it will work. It also allows us to, God forbid if it doesn't work, migrate it back. It gives us a path to revert that change. So when you write a migration script, the idea is that it is backwards and forward compatible, meaning we can migrate to a new revision and we can also migrate back to a previous revision. And so in that sense, it is considered more safe because if it doesn't work, we can just roll it back. What database migration libraries are available to us? We have Alembic, Django migrations, Yo-Yo database migration, Migrate, SQLAlchemy Migrate, SQL Migrate Runner. I'm sure there are more, but today I'm going to talk to you about Alembic. It's pretty popular library. Most people, most Python developers I know, unless they're using Django, use Alembic. So how to configure it, it's very simple. You can choose to or not provide a script location where your migration scripts will live. And you also specify your database connection URL here. And that's basically it. You're done. Let's take a look at an example. Commonly, database migrations, just like when you're developing a feature, they may take multiple PRs to get there, or in this case, multiple migrations to make or reach that final change or desired state. So here, for example, we're adding a new organization table and the concept of organizations into our database. And that's going to require several steps. First, we need to add the organization table into our database. And then we need to define a relationship between the existing groups table and the new organization table. And then finally, we're going to default or define for all of our existing groups an organization that they belong to. So basically, no group is allowed to be without an organization. And so let's get started. It's very simple to create a migration script. We just do Alembic revision, and then we have this -m. This is basically the same thing as you would provide if you were doing a git commit. It's just a simple little description of the change that you're making. And so that will spit out our hash of our revision number, basically, of our migration, and then that simple little description of what it's doing into a Python file. And let's take a look at that Python file. What does it look like? So here, it just provides you a nice little template. So we have an upgrade function and we have a downgrade function, and those are left empty for us to fill out. And then we also have this revision information at the top. So we have revision, which is the current revision of this particular migration, and then we have a down revision. So that's going to point back to the previous revision, which in this case is none because there aren't any previous revisions. And so what this is going to look like after we upgrade is the head revision is now going to point at our current revision, and assuming we continue writing our migrations, eventually, the head will point at some later revision. So let's fill out that function for adding a organization table into our database. So what this looks like is we import Alembic, and then we call create table, and we provide the following information. It's going to have an ID, a name, and logo column. And then, of course, on downgrade, what do we want to do? We just want to delete that table. One thing, don't forget to add your SQLAlchemy model for this, right? We migrated our database, but we also want to add that model into our code so that we can actually use it. So running the script, we just say Alembic upgrade head, and ta-da, it is pointing at our latest revision. But oh my gosh, everything is broken. It's okay because we can downgrade it. Very simple. And ta-da, we're safe. We have avoided major problems in production. Let's do the next migration here, which is we're going to modify the existing group table. In this situation, the group is going to point to or belong to an organization, right? So we're defining a relationship between the group and organization tables. And so what does that look like in terms of code? We're going to add a column to the group table called organization ID. That's going to be a foreign key of organization.id. And what do we want to do when we downgrade it? We just want to drop that column. And of course, don't forget to add this relationship into your group model. All right, and finally, we are going to modify data on production. Terrifying, but it's going to be great. So we're just going to take all of our existing groups that we have in production and migrate them to belong to a default organization. So if the group doesn't already belong to a default, or it doesn't already belong to an organization, then we're going to grab it and we're going to set the organization to our default organization. And notice that we've left our downgrade function empty in this case. This is a little tricky, but this is kind of one of those migrations that's going to be very difficult to undo later on because more groups are going to be added. They're going to belong to perhaps a default organization, perhaps not. So if we really wanted to downgrade this properly, what we would have to do is when this script ran on production, we would have to log and keep track of all the groups that we modified and set to a default organization, and then add those into the downgrade function, and then that would define our downgrade, and then we would truly be able to undo this change. But in this situation, elected not to do that. Wasn't really necessary. The way we would kind of like undo this change if we were going to undo it is basically just wipe out all the groups belonging to an organization. But something to point out here is we are using models here. We're using the organization model, and we're also using the group model. And so what you might be tempted to do is something like this, where we just import from our existing models in our code. But that is a big mistake. You don't want to do that. And that's because those models may change over time, right? Those are not necessarily static. And this migration assumes that those models look a certain way. It assumes that they have certain columns. And in 2 years from now, those columns might not actually exist in those models. And we always want our migration script should work for years to come. We should be able to, 2 years from now, revert this migration if we want to. And so in order to do that, we define our models inside of this migration. And this will ensure that we can run this migration script in 2 or 3 years. All right, lastly, I wanted to just talk about a couple issues you might encounter with SQL Alchemy in the real world. And one of these is lazy loading. So what is lazy loading? So lazy loading looks like this. So we say we pull a group out of our database, and then this group has a list of members on it. And so that list of members are a bunch of user objects. And so then we might do something like this with the group.members, where we grab the name from each one of those members. And so you might expect that this would just go ahead and grab all those members in the first query. And so you might expect this to just be a single query to the database. But in fact, what this actually looks like is SQLAlchemy lazily loads things. So it doesn't query for extra stuff until it realizes that you need it. And so this has the unfortunate symptom of running the initial query for the group, and then when you actually need the members, then querying for those members. And so what this actually results in is the number of queries blows up. So instead of having a single query to the database, now we have 1 plus the number of member queries to the database. And you can imagine that if we have 100 members, this is going to be very, very, very bad. And so how we combat this problem is we use this join load function in SQLAlchemy. We just say, grab those members up front and join them with this initial query. And so then in this situation, SQLAlchemy is going to go, okay, I see that you really do want me to query for all those members in this initial query, and it goes ahead and populates that members list with the user objects. So another problem you might encounter in the wild, although this is very rare, it does sometimes happen. Occasionally, SQLAlchemy will unexpectedly generate a query that you did not intend it to do, which in some situations can be a very not performant query. So here, basically, we're just trying to count up all the annotations that a user has created. And unfortunately, in this situation, this query ends up looking like a nested select statement, which is very not performant. And so instead, what we would like to do, we have to tell SQLAlchemy to do something a little different. So we import this func.count, and then we tell it to count all the annotation.ids, and then we can see that our select statement is as we would expect it to be, and it's a nice performance select statement. So in review, things we have covered, building models, types of indexing, connecting to the database, connection pools, keep alives, building queries, database migrations, and some gotchas with SQLAlchemy. I hope this talk has been beneficial to you and that you've learned something. If you have any questions, leave them in the comments and I will answer them asynchronously.